I'm gonna talk about my assignment 8. So the first problem of the assignment 8 is Euler's problem. So what I'm going to do is to transform this Australia map to a graph, and each state in Australia represents a node, and there are 6 nodes in total. And then I'm gonna connect every 2 nodes by edge if the state have common border. So the first thing I have to I have done is to construct the graph, and the graph is in a dictionary structure. Uh, the key is the node and the value is the age. So uh, what I just input the node. The first node is the Western Australia, and then find the other 2 nodes adjacent to Western Australia. So just put the other 2 in the age list. So and then just do the same thing to the other 5 states. So that's how I construct the graph. And the next thing is to determine if the graph is Eulerian. So if the graph is an Eulerian, the degree, which is the number of the age of each node, is even. So I just need to count the length of the age for each node. So if their node have odd number of age, it is not Eulerian. So the first thing I did is to build an edge number list to install the edge numbers for each node. And we can see here is the edge number for each node. So and then I'm gonna build 2 lists to store the even number and odd number, and then I'm use a while loop. So if the length of the edge number list is greater than 0, and then I'm gonna pop out the number in the list. If the number is even, I'm just append the number into the even list. Else I'm append the odd number to the odd list. So if the length of the odd list is not 0, which means there is an odd number of edge in the graph. So we could say the graph is not Eulerian. Else the graph is Eulerian. So in this case, it is obvious that we have 3, 5, 3, 3 edges, so, which is the odd number. So it is not Eulerian. So we can also use the NetworkX library and to determine whether the graph is Eulerian or not. It is really straightforward. Just create an empty graph and add nodes to the graph and add age to the graph, and then use this function to determine if the graph is Eulerian or not. And then when we add a new node T and connect the new node to the Northern Territory and South Australia, Queensland, and New South Wales, and then we are gonna to build a new graph, which we need to add a new node, add the new edges, and add the new edges connected the new node to the other node, which have the common border. So, and then I use the Eulerian function to determine the result shows the new graph is Eulerian. So I'm gonna use another Eulerian path function to show the Eulerian path. So which means we start from the Victoria and work around and go back to Victoria. So here is the path I found. So this is about the first problem.